Hello, and welcome to the climate section of this program. My name is Julian Spector. I'm the staff writer at Greentech Media, where I report on clean energy and deep decarbonization, the energy transition that's going on. I also write a weekly newsletter about clean energy called Bright Ideas, brightideas.substack.com. But I am here today to interview Dr. Jennifer Holmgren. She's the CEO of LanzaTech, which is involved in taking carbon and turning it into useful things, for plastics, for fuels, and really kind of revolutionizing what carbon pollution means and can do in the world. So the plan for today, we've got an hour. Jennifer's going to do a talk to kick things off and explain what her technology is, what her company is. Then we'll talk for a while. We want your questions. So, go ahead, put those into the chat function, and I will do my best to incorporate those into the conversation. And that's what we're doing today. So let's bring in Jennifer and see what you got to tell us.
Thanks so much, Julian. And it's really a pleasure to be here. I'm going to take you guys on the wild side. I want you to imagine a world where there is no such thing as waste, where everything that we use in our daily lives, we use over and over and over again. It's a world where we're very much part of nature, because nature uses everything. And in fact, in nature, waste is food for the next generation of trees, etc. And that's what we want, is to create a world where waste becomes the feedstock of the next products. So what LanzaTech does is it converts waste carbon into ethanol. So we have a bacteria that eats carbon monoxide, hydrogen, and carbon dioxide and converts that to ethanol. Now, where would you find such a thing? You can find carbon monoxide in lots of industrial sites, steel mills, refineries. You can also take solid waste like agriculture residues or municipal solid waste or plastics and gasify them. And of course, you can also use electrolysis. When green electrons become cheap, you can use those to convert CO2 directly by coupling it with hydrogen in electrolysis, either from a flue or from direct air capture. This is all the same technology using all these wastes. And what we can do is turn it into ethanol. We can take that ethanol and convert that to jet fuel. We can, of course, also take ethanol and convert it to packaging and all the things you use in your daily lives. Our real dream is to use synthetic biology someday to completely bypass ethanol and go directly to making products that we use in our daily lives just from these waste emissions. Now, I know this sounds like science fiction, but it's not. This is a plant that we built, our first commercial plant, operating in China at a steel mill, where it takes a steel mill gas and converts it to ethanol. We've made 16 million gallons of ethanol to date, and we've counted up that prevents 90,000 tons of CO2 from being emitted and reaching the atmosphere. We put 50 billion tons of CO2 in the air. So one plant that mitigates 90,000 tons isn't going to get it done. So what we're doing is now, after our first commercial, is we're diffusing the technology. These are plants that are being built right now. These are not just discussions. We're having multiple plants in China. The next one will be up and running at a ferroalloy plant in March of next year, gasification plants in India, et cetera, et cetera. So we're trying to contribute to global carbon reduction. Now, if you make this much ethanol, of course, you can put it in cars, but hopefully someday soon we'll all be driving electric vehicles. So what else can you do with ethanol? If you've used this waste to make ethanol, we've introduced a product with our partner in Switzerland, Mebel, who has put our ethanol in their cleaning products. Imagine preventing pollution in China and using that to clean your floor in Europe. The other thing, and this was announced this morning, we've been working to take our ethanol through ethylene and convert that to products. polyethylene, for example, which is used in all sorts of bottles. And as you can see this morning, L'Oreal announced that they had actually made shampoo conditioner bottles as a trial using recycled pollution. This is really, really exciting for us to show that we can take ethanol and use it as a building block to make other products. And of course, you're not used to thinking of that, but most of you know that today the world makes almost 200,000 tons of ethylene. Ethylene is the key commodity building block of almost everything we use in our homes. And so what I want to do is be able to get away from that and use ethylene derived from recycled ethanol to make things like jet fuel. And we launched a company called LanzaJet that is doing just that, jet fuel technology from ethanol. And as I mentioned, L'Oreal for PE. Now, the other thing that we use a lot of in our homes is fibers, polyester, if you will, PET. And today, PET is made from ethylene, and we're going to be making it from ethanol. And at the beginning of next year, we'll introduce products where the PET was derived from recycled pollution. But what I really want to do is this: use synthetic biology to bypass that whole chemical value chain there, which is all pretty toxic. Ethylene oxide is explosive. Use benign chemistry to directly make the MEG. And in fact, last week, the Department of Energy announced that with our partners, Lululemon and Waste Management, we're actually going to recycle some of their wastes directly and make them into MEG and then recycle them into products again. Because frankly, making MEG from waste is not enough. You have to show that you can put waste into a cycle where you use it over and over and over again. This is what we want to do. And in a few years from now, I hope I'll be telling you about that. So you can see a transition from ethanol for cars to ethanol being converted to other products to eventually making other products directly through synthetic biology. But we're not just doing that because we like to do synthetic biology. We're doing that because we have a reason to change the way we make things. This is really what our world looks like. We're at 1.1 degrees of temperature rise, and the suffering surrounds us. Every single day, somebody has to live with the impact of this climate change. And happen to agree with Tom Chi, who said we have to stop talking about how many degrees of rise we're going to get. 2, 4, 6, they're all bad. What we need to do is change. We need to fundamentally change. And I believe that technology changes the way we view the world. Technology is what opens our eyes and transforms us so that the change is not a sacrifice. The change is an opportunity. And I know that's what all of you guys are trying to do in the engine, trying to develop tough tech that changes everything. And you have to. We have to do this. And so I will leave you with one of my favorite quotes, which is from Muhammad Ali, who said, "Impossible is just a word thrown around by small men who refuse to change the world and would rather just live in the world they're given. Impossible is not a fact. Impossible is just an opinion. Impossible is nothing." And I know that a lot of you get the word impossible every single day as you try to do what you're doing. And what I would say to all of you is, do what I do. Impossible is just a dare. Thank you so much for taking the time to listen.
Okay, wow. Well, I think I wanted to start with that question of what is possible, what is impossible. I mean, what you're talking about in some ways sounds like alchemy. It sounds like you're taking this waste that we don't want and turning it into something valuable. And obviously, it's not magic. This is based in science. So let's start there. How are you actually converting carbon into useful feedstocks for materials? What's the special sauce that makes this all possible?
Well, we have a bacteria. So you're used to fermentation, taking sugar and making beer out of it, right? With yeast. Okay, take out the sugar, take out the yeast. It's the same thing after that. So instead of yeast, we have a bacteria. What the bacteria likes to do is eat CO, carbon monoxide, hydrogen, carbon dioxide. That is its sugar, if you will. So it eats that and it makes ethanol, just like conventional fermentation, just a different feedstock. And what we do practically is at the steel mill, if I had shown you a long view, you would have seen a green pipe coming in. Basically, instead of emitting the carbon monoxide that comes off the steel as you're reducing it, and then they take that out, the fluid CO2, we intercept it and we compress it into our reactor. And then the bacteria sees the gas, eats it, and makes ethanol. That's how it works. 10 years ago, it was rocket science. Now it works.
Yeah. Okay. That's very interesting. And can you talk a bit like where is this bacteria from? How did you get your hands on it? You know, how did it evolve that kind of very useful capability?
Yeah. So actually, this is our great grandfather. Actually, this was one of the early bacterias that lived on planet Earth before oxygen became an important part of our atmosphere. Actually, oxygen will kill this bacteria, so it cannot survive in the air. So the only places you find it now is where there's no oxygen, buried in a sea vent somewhere underneath the ocean, etc. And when people find bacteria, they often identify them and then they send them off to a library. There's a couple of bacteria libraries or organism libraries. One of them is in Germany. And so the founder of our company, Sean Simpson, ordered this bacteria that he knew could convert gases. And it wasn't selective, so you wouldn't have been able to commercialize that. But basically through directed evolution, just like you do breeding plants, we basically got it to a point where it's completely selected to making ethanol, and that allowed us to scale it and have it make economic sense.
Gotcha. And I guess I'm interested in this question of if it's doable and it actually is possible, how come we're not doing it already? You know, why aren't there a ton of companies, you know, using these seemingly magical bacteria to solve our world's problems?
You know, actually, that's a good question, but as with everything else, it's obvious and it's easy after it's done. Mm-hmm. There were people working on this. There were people obviously looking at gas fermentation, but there's a couple of problems you have to solve to be successful in gas fermentation. One of them is sugar and yeast hang out in water, sugar soluble in water. It's really easy for the yeast to eat the sugar, right? These gases are not soluble in water and the bacteria is in water. So you have to figure out a reactor design that gets that gas efficiently to the bacteria. So it's a really major engineering challenge to get that right and to do it in a way that's cheap, right? I mean, you could do it for sure in the lab, but then when you scale that, either you use too much energy or it's too expensive. So that doesn't work. So that's part of the reason you have to solve that problem. You have to know how to evolve the bacteria to get it to do what you want it to do. And actually, the other thing that's really interesting that people said couldn't be done, we use a steel mill gas, right? Which is rich in carbon monoxide. There's no hydrogen there. So this bacteria actually makes its own hydrogen from the water, okay? And a lot of people would have said that that's impossible, and they would have looked for something a gas that was carbon monoxide and hydrogen, right? Both. But those are more expensive, more difficult to find. And so this allowed us to make the technology cheap, right? Because we could just put our reactor up to a gas that had no real alternative use. So there were a lot of prejudices, but we tackle one prejudice at a time until here we are.
Yeah, that's fascinating. Well, we have some questions coming in from the audience already, which is great. Keep those coming. So the audience wants to know, how do you make this work in a world where you don't have a carbon tax in most places? You know, it's generally pretty cheap to just emit the carbon and warm the atmosphere with it. Does your business model depend on there being a cost to that, or are you able to make it attractive to your partners, before that policy comes around?
Yeah, no, so without that policy framework, the technology only makes economic sense in certain parts of the world. Places where the price of ethanol is high, then you can make economic sense. It's a waste feedstock, so it's very cheap. And if ethanol price is high, it's a really efficient and selective process. It makes sense. You cannot put this somewhere where ethanol price is low, etc. So yeah.
And for the audience, what are some regions where it is, good, in terms of ethanol pricing?
China, India. These are both places where we're building because ethanol price is high, especially if you have a biological derived ethanol, you get credit for that. In the United States, there is a credit for bio-derived ethanol, but it's actually not technology neutral. It has to be a plant, some type of green thing that does photosynthesis have to be involved. So it doesn't work. It doesn't work for us. And that's why you'll see there's no plants in the US right now.
Gotcha. So that's interesting. So in the way that, recycling in general is valuable when it's a cheaper way to get the materials you need to build something new, that's the framework you're applying, but with carbon instead of aluminum cans or something?
Yeah, that's right. And that's right. So to make the ethanol right now, right, that's right. You have to have a framework that already exists that allows your product to make money. When carbon taxes come in, then we could do this anywhere, right? And but this whole carbon capture and reuse concept, that the ability to turn into a product that you can sell, I think will help drive technologies before carbon taxes come into play. Just because they're just not around the corner, right? But we got to start decarbonizing. We got to bend that curve, right? So, it's good that there is the ability to make other products.
And then what's the capital costs look like if you're, putting these pipes onto an existing plant? How capital intensive is that? Is that something that you pay for, or does the steel mill, agree to invest that in the hopes of benefiting long term? How do you approach that?
Yeah, so actually right now what we've been doing is licensing the technology. We've used all the capital we've raised to develop this platform. And so our partners actually pay for the steel in the ground. And if you do this in China, it's a $50 to $60 million exercise. If you do this in Europe, it's upwards of 100 million. So it's not cheap. So the other thing you have to find is not only the right places to put this in, but like-minded individuals that believe in a future where this is going to be important. And so they want to start getting used to technologies that allow them to create this change. So when carbon taxes come, they can pull this out of their pocket.
Interesting. So it's anticipating policy change down the road and getting ready. And does it require a steel mill to want to get into the plastics business, or are they seeing this as a new revenue stream that is additive to the process of making steel they already do?
Yeah, it's de minimis, right? I mean, this would be the tail wagging the dog. This only adds a small amount of revenue, but it takes care of their emissions. But they don't all have to become experts in selling fuels or chemicals or anything else. So our partner in China is happy to sell it. They have the market. They know their potential customers. Other partners across the world want us to help them sell it. So we have a couple of refining companies like Indian Oil or traders like Mitsui who are our investors. And so they have been helping the steel mills think about, what do you do with this fuel once I make it?
Gotcha. And then in terms of the bottles, you're working with L'Oreal. Is there a pathway to a point where plastic bottles made from your process end up being cheaper than conventional plastic bottles right now, or does that require scale? Is that in the cards?
Yeah, that's a great question. Plastic bottles today are made from fracked natural gas or naphtha, which, is pretty rock bottom cheap right now.
Mm-hmm.
I think it's going to be a really long time with these oil prices for anything like what we're doing to even look economic. I think economies of scale will have a role to play, but frankly, I don't think without any incentives that they will be the same price. I don't expect that. But we have brands who are willing to pay a little more to save the planet, and that's good.
Mm-hmm, mm-hmm. And what does that come out to for the customer buying this bot? Is it just a very incremental price addition that you might not even notice at the drugstore?
Yeah, so some of this, since this is such a small part of what's actually the pricing, the bottle, the customer may only see a small difference, or even in some cases, none at all. I'm working with a brand who will absorb the costs in the manufacturing of the products so that they make product available to everybody, right? So you can choose to have a carbon smart product without having to pay more money.
Gotcha. And playing this out long term, do you think you can get to enough scale that you eventually don't need the original fossil fuel inputs? Like, will this ever be able to do 100% of the bottle, or is it always about, reducing the carbon intensity of a bottle that still needs some fossil fuel that's refined as an input?
Well, I mean, the answer to that question is I don't know. I mean, I can try to predict and I can say we're going to substitute for everything. But look, the way I think about it is we are going to have to substitute for everything. We've got to get to net zero, and we've got to take carbon out of the air as well. So at the end of the day, we have to strive for that. How realistic is it? I don't know how realistic it is right now, but I hope with all the people sitting in this room and their collective wisdom, we can achieve that, because quite frankly, that's what we have to do.
Yeah, I mean, this reminds me of, in the presidential debate just recently, we had Vice President Joe Biden mention transitioning away from oil, and now that's become a discussion of, can we get rid of the oil industry? And we do get plastics from refining oil. So I guess do you see technologies like yours providing an alternative where, maybe we don't need to keep extracting fossil fuels eventually if there's enough solutions like what you're up to?
I actually do believe that. I believe that there are enough technologies out there either already in play or being developed that can do that. But I do think we have to think differently, right? If the way we measure technology is by saying, well, I'm going to have to make, 200,000 barrels a day of production capacity to make it matter, we don't win. The problem is that the incumbents, it's been optimized over 150 years, right? 120 years, whatever, it's up there. And we cannot compete with new technologies by trying to do everything exactly the same way the old technologies have worked, right? So in my view, we can make everything, but we have to do it in a distributed world, okay? We cannot do it in a centralized, really huge refining world. And we do it by being selective. Synthetic biology is selective. A refinery takes a barrel of oil and turns it into 30 products, right? And it needs 30 unit operations to do that, right? I'm making up these numbers, don't quote them.
Yeah.
But it's something like that. And so then on the other side of the equation is synthetic biology. I just told you I can make one product selectively, right? So I don't need scale because I don't need 30 unit operations to get to the products I need. We have to think differently. We are never going to get out of this mess if we try to do it exactly the same way and try to keep brute forcing new ideas into a box that we just need to throw away.
Yeah, I think that's a fascinating point. So traditional refining you're taking the stuff out of the ground and then kind of physically separating different layers in terms of the, you know, light and heavy and all of that. Whereas you can just pinpoint what do we want and make the synthetic biology process to create that single desired output. And I guess what does that do to the capital investment required in your kind of refining process? Is it, you know, do you have a ballpark kind of fraction of what it costs to set up one of your factories versus the entire conventional refining facility?
Right. So well, I mean, I just told you $50 to $100 million to build one of ours. Our production capacity is a lot less than a refinery, but theirs are, you know, billions of dollars, right, to build a refinery. So can I aggregate, you know, 100 of these units for the price that it takes to build a refinery? And I think you can. I think once we get to scale in multiple locations and multiple feedstocks, we'll drive the cost of one unit down enough that when it replicates, the aggregate cost will be equivalent to a large refinery.
Wow.
That's what I'm going
No, that's really interesting. And we've gotten a few inquiries from the listeners about what happens when you burn your, you know, fuels and there's still carbon emissions from that, right? Even it's synthetic, so it's not as bad as gasoline or traditional jet fuel. But do you end up needing some sort of carbon capture if you want to truly neutralize the carbon emissions from your products, or how do you think about that?
Absolutely. That's a great question. So that's absolutely right. Carbon in, carbon out. If you combust it, you're going to get the same thing. So if I put ethanol and it substitutes for gasoline, I'm still going to get emissions when I burn them. So the ideal solution is indeed to recapture all of that back. And this is why carbon capture is so important, right? Long term, to get to zero, that's what you need to do. But that's also why for road transport, right, electric vehicles are the answer, right? And electric vehicles with a green grid. When it comes to plastic, I do lock the carbon in the plastic, right? And then my goal, so I don't have to, you know, I just want to keep reusing that. I lock it in, reuse it next time I need it. I want everybody to return their plastic, to return their to a place where they can be collected and reused. I mean, that's the point. But you know, I would add just one more thing. I want to talk about aviation for a second. These synthetic hydrocarbon fuels have other benefits, okay? They don't combust exactly like petroleum, kerosene. So if you combust them, yes, you get the same carbon emissions. So what you've done as a carbon benefit is you've kept carbon in the ground, right? Because you don't need to drill oil out of the ground to make that equivalent amount of kerosene. But we've done a lot of work with NRC Canada where they've shown that our type of jet fuel reduces contrails, reduces particulates, etc. So that's also why I say we don't want to try to measure ourselves in the other box. You want to just show some of the additional benefits, because frankly, number one priority, climate change, but pollution is a problem too. Dirty water is a problem too. So we need to just regenerate the whole environment and keep fixing all these things. So we need to find new solutions that are better and different.
No, that makes a lot of sense. And just briefly, if we're looking at a future where jets are burning your fuel, but then capturing them, I mean, what's the technological pathway for that? Do you have to have mechanisms on the plane itself that catch emissions, bottle them up while you're flying?
I mean, I don't know that. I would say that's not what you have to do. This is why people really like to talk about net zero. At the end of the day, we got to get to zero, but we don't have to do it on site at that specific place, right? So if you stop and think about it, do I put something on the back of a plane to capture it, or do I ensure that all the technologies that are doing direct air capture are successful, can scale? Do we do all of the types of things that balance the ecosystem? To me, that's the answer.
Gotcha. Well, I wanted to get into more of the kind of industrial politics around this, because you're sitting at the intersection of a whole bunch of very big, very powerful incumbent industries. You've got, oil and refining and plastics, jet fuel, also, I guess, waste management and the kind of existing recycling infrastructure. So as a startup, how do you navigate so many different incumbents at once? And, are you setting out to destroy the incumbents like some, electric car makers kind of take a fairly aggressive stance towards gas-powered car makers, or do you see this as more of a collaborative, partnership approach?
Well, first of all, I think it's got to be collaborative because one doesn't move quickly by oneself, right? And we cannot make massive impact. If you look at our investors, we have chemical companies, we have oil companies. They're all committed to a transition. What we might disagree and debate is how fast do we need that transition? But they're fully on board that they need a transition, and that's why they're working with us. I would say the one thing, we're not going out to destroy industries, we're going out to transition industries and to create new ones. But I will tell you, if I'm using the destroy word, we have to change what we do fundamentally, right? Our economic and carbon system is flawed, right? We've created a very linear approach and a linear and wasteful economy, and our planet isn't going to be able to survive that. So if I were to go destroy something, I'm going to work really hard to show people there's another way that allows that to disappear, without people laughing at you and saying, well, show me. When you show me, I'm going to show them. I'm going to show them.
Mm-hmm. Mm-hmm. Gotcha. Well, let's dig into the kind of, financial approach, how you were able to build up this company in the first place. This seems like pretty much the definition of tough tech. It's you have to master special bacteria. You have to figure out all these different, physical pathways for capturing the carbon and putting it into your process. So could you talk a bit about how you attracted investors early on and, got through the early stages of proving out the technology back when it wasn't necessarily a surefire thing?
Sure. So when the company was founded, it was founded in New Zealand in 2005. And the original investors were local New Zealand investors, K1W1 Kiwi. And so the founder, Sean Simpson, got early stage money from them, and then Khosla Ventures. And that allowed the company to start to grow. As we got bigger and bigger, we were needing to attract strategic investors. And the reason for that is most funds have 10-year lifetimes. And you can't really do tough tech from a small test tube to commercial scale to making enough revenues to not need to raise cash in 10 years, not if it's a disruptive technology. So we enlisted a large number of strategic investors like New Zealand Superannuation Fund, like BASF, like IOC, like Suncor. These are all people who are interested in the technology, not necessarily in the time to a return. So we married the initial financial investors with the strategic investors, and we're able to get a group that is aligned in creating something different, something disruptive, over a period of, say, 20 years, which I think is a reasonable period.
Gotcha. And then you've also been working with the strategics on ways to, scale up the production with some commitments to capital so that you'll be able to keep growing when you meet the milestones, right? Could you talk about how you approach that and what that lets you do?
Sure. So what we did when we founded LanzaJet, so what we did is we spun out the company that does the technology to take ethanol to jet fuel. And we needed to build a demonstration scale facility. And thanks to the Department of Energy, we received funds to help us build a 10 million gallon a year jet fuel production facility. But what we wanted to do is once we built it, we needed additional investment. That funding wasn't enough. So what we did is we said, we're going to go out and raise cash to build this plant. In the traditional process, what you do is you build the plant, you raise the cash, build the plant, and then once it meets all its KPIs, you go out and you raise cash for the commercial scale. So what we said is, look, that 3-year time between starting to meet your KPIs and raising the cash and starting construction on a big commercial is wasted time, okay? So what we want to do instead is bring in investors who are committed to scale, because it only matters when it scales, and invest in building this demonstration. And then if the KPIs are met, they're committed, they're part of the company, and they're already working on developing commercial sites. So then they commit to investing on that commercial plant. So basically what that does is once you meet your KPIs, you've got a fast path to that commercial plant rather than having to go to the market again. I really think we need to do more of that. We need people to make those types of commitments. We just can't afford all this time in between each step. You know, crossing the valley of death should take a couple of days, not a couple of decades.
That's a really good point. And I guess when you describe it that way, it just makes a lot of sense. You know, why not kind of get that buy-in and allow for a more seamless scaling once you meet those milestones? So why does that feel so new? You know, is this a matter of getting strategic investors that do have that long-term vision and you know aren't so afraid of the technological risk that they don't want to commit up front, or you know, why don't we see more of that?
Well, as with everything else, you got to do it once and then it makes sense, right? But I think my view is we shouldn't underestimate capital processes, right? We're talking about $10 million, then another $30 million, right? So how do you get that approved at the beginning when the technology is not proven? You have to go to your board and get 40 million approved, or it depends on your capital process for your company. But think about the difference in going in and asking for $10 million versus saying, well, I'm kind of committed to 40 if this works, right? So you have to approve 40. I think that's one of the problems with tough tech, right? Is the massive capital that's required. And what are the capital approval processes that you go through, your partners go through, et cetera, et cetera, et cetera. They're massive. They're frightening.
Absolutely, yeah. And this makes me think of the Greentech 1.0 era around a decade ago, or Khosla and other investors put a lot of money into these biofuel startups and various different ones that on the whole didn't turn out as well as investors had hoped. What do you think the problems were the first time around, and how are you applying the lessons of that first wave of clean tech venture to keep things going and do it more sustainably right now?
Yeah, so that's a great question. And first of all, just so we're all clear, if it weren't for Greentech 1.0, there would be no Greentech 2.0, because there are massive lessons learned, right? The first lesson is tough tech takes a lot longer than a conventional fund has of 10 years. So how do you invest and get it done and get returns to investors in the timeline that they need, right? That was one of the things. And so a lot of the entrepreneurs tried to fit their process to the investment horizon. And guess what? In technology, you don't get to skip too many steps. You might skip some steps in financing, but you don't skip steps in technology, I'm afraid. And so I think that was one of the problems. And so I think the lesson learned is technology takes what it's going to take. Try to find a way to accelerate it, but technology takes what it's going to take. We have tools, we have approaches. but we still need to go through the process of scaling, and we need to get it right, because nobody wants to build $100 million boat anchor, right? And so that is the point. So I think that's an important lesson. I think the other lesson is, frankly, that small companies can do it. What 1.0 showed, despite the fact that many of those companies didn't make it, some did, right? And the ones that did showed that you don't have to do new process technology inside a $50 billion corporation. That's the second lesson we learned. They gave people hope that this could be done outside of that. And then I think the third thing it showed us is you got to bring in strategics. You've got to find a path to commercial and a path to scale, and people who are patient and have the ability to help you down this path.
Gotcha. So is it fair to describe that as a move away from a more typical Silicon Valley approach to scaling technology, and tried to fit hardware and climate tech into that model originally, and it wasn't quite the right fit, and now there's more of an understanding of going to the long-term investors, or maybe utility companies, or energy companies, and are able to think in these more decades, if not centuries.
Well, what I would say actually though is that you need both. You need to figure out how to marry the two, because a large corporation has a really slow decision-making process, and that works really well when you need $20 million, $50 million. But when what you really need is 500,000 of seed capital, that process is too long. And so I really think that bringing together private investors, or the VC world, as you're calling it, corporations, and governments increasingly have a role to play and increasingly contribute. I think we really forget sometimes how much funding goes into early stage work in academia that then becomes a company, or into small companies that are then able to use that funding to develop a technology or an innovation and then scale it. So I think all of these pieces have to come together to create this really fast process that we need to be successful.
Yeah. Do you think those pieces are now in place? Or do you have any wish list items for the innovation ecosystem that, if you could snap your fingers and make them appear, you would?
Well, first of all, we're sitting here having a conversation with the engine, which was specifically founded to help these tough technologies scale, right? So there's already people rethinking the VC model or that approach to enable the things we're talking about. So that transition has started. If you want to talk about a sexy fund that's doing it, right? Breakthrough Energy Ventures, right? Which I think is partnered with the engine. They're also doing it, right? They changed their 10-year fund to a 20-year fund, and they're trying to think of different ways to create the success, the ecosystem that's required to create success. So I think that's already starting to happen.
Yeah, no, there's this proliferation of groups like the engine focused on these problems, and it kind of like solely dedicated to this instead of trying to mix it in with the rest of their portfolio. What about as far as government support? I mean, you've gotten money from the Department of Energy, but are there other sorts of policies or research programs you think would be a good idea for the United States, to support more companies like you?
Sure. I think we need, I think, because I believe we need to do this more quickly, I think there's two things that need to happen. Innovation funding needs to be dramatically increased, but it shouldn't just be for very early stage or filling the funnel, right? You want to go all the way down. So what that means is there also needs to be funding for pilot, for demonstration, and for the first commercial. Even the first commercial has a lot of risk, right? It's the first time it's ever been done at a certain scale. And what you have to have is investors who are willing to take that level of risk. And like I said, it could be $100 million boat anchors. So I think there needs to be government funding all the way through. Once you've built the first commercial, then let the market do it. But getting it there it requires massive amount of funding. So the beauty of that, of course, is the massive amount of funding leads to massive amount of jobs. It is actually new technologies and new approaches that create jobs, right? Big corporations are about efficiency and optimizing and reducing costs. Startups are about scaling and growing as quickly as you can. So that's where the jobs are. And it's also where the infrastructure gets built. So that's one thing that needs to happen. And the other is, quite frankly, we need a price of carbon and we need it to be technology neutral. Low carbon fuel standard, completely technology neutral. You show me a reduction, I'll pay for it. Other approaches, select technology. There's nothing I hate more than somebody selecting an approach. If you select an approach, you fundamentally focus only on that. And what that means is all of the other ideas take a back seat. Right now, we need all of the ideas to have a seat at the table for us to be successful.
Gotcha. Well, we have a few more questions from the audience in our last 15 minutes here. So anyone else, if you have those, get them in now. But this one's kind of interesting is, what do you think is the place of retrofitting existing industries to make them carbon neutral or negative versus creating new opportunities and technologies to replace them? So like how much effort should we spend trying to clean up the dirty stuff that we've had for years and years versus replace those wholesale with newer, cleaner industrial processes? What do you think about that?
I think you need both. I know that seems like a cop-out, but it's not. We have to bend the curve, and we have to bend it now. If we're going to bend the curve, right, there isn't enough time for all of these new things to take place. So we have to, as we fund those, we have to start to reduce emissions from existing assets. And I see a lot of people talking about direct air capture. Right now, people talk about blue hydrogen, green hydrogen, brown hydrogen. You know, how is it made? And what is it that's happening on the back end to clean it up? You know, frankly, electric vehicles were pretty dirty initially, right? Because they were powered by coal. But by letting them flourish during that time, they were able to get down the cost curve. So now when the power is greener and greener, you've gotten things to a point where you can proliferate them. So I think we need to focus on carbon capture for existing technologies. I think we need to start mandating that, quite frankly. And I think at the same time, we need to start to develop the technologies that reuse carbon. And then I think one of the things that's going to have to play a role is direct air capture. I know a lot of people don't think that will ever mean anything, but I do. We're going to have to take carbon out of the air, and we cannot plant enough trees fast enough to take all the carbon out of the air. So we're going to have to do it with a machine. It's that simple.
And would could a direct air capture facility then become a pipeline that feeds into your ancient bacteria, and you just pull it out of the air and turn it into plastic?
Absolutely, because you take the direct air capture machine. Now you've got green power, because you couldn't do direct air capture without green power, right? It's a big energy user. Direct air capture, and then you've got an electrolysis machine, right? And then you have our technology as an example. You can make anything you want at that point.
Yeah, no, that's interesting. And I think you're right it does depend on the industry. So I could see an outlook where, passenger vehicles, make them all electric, don't need to worry about capturing emissions from tailpipes because you just get rid of the tailpipe. But then you figure out which ones are too hard to replace entirely, and then put in the effort to retrofit those to make them cleaner. Is that kind of the framework?
Yeah, that's right. That's one approach. Absolutely. Absolutely. Yeah.
Gotcha. Then another one from the audience is how do you figure out which products to prioritize? You've got the jet fuel, you got the plastics, but what's your strategic thinking around, is it about practicality and which ones you can knock off first, or is it about the carbon impact of particular products? What's the decision making look like for that?
Yeah, so the first thing we had to pick is ethanol, right? So it's something that the bacteria knew how to make naturally. There's a lot of concerns around GMOs, et cetera, and getting a new technology out the door is hard enough without have to deal with some of the regulatory issues associated with that. So we focused on what the bacteria, plus it's the easiest, right? If it knows how to make it already, just optimize it. So we start with ethanol. So then the question became, what do we do with that ethanol? Because we know eventually ethanol will not be in that high a demand, right? And jet fuel is one of these markets that we really felt was going to be very difficult to decarbonize. So we've been working on jet fuel for 10 years, kind of in the background, right? As we were developing and optimizing the ethanol scaling technology, we were developing the jet fuel technology. After that, packaging, fibers, et cetera, that was just more of interest from brands, to be honest, of which ones they wanted. If we could find a partner who cared about a plastic, then we would pick that one. At the end of the day, we just needed to show that all of the products you can make from ethylene today, you can make from ethanol. And that's how we selected those. I would, however, add an overlay to this. We focused on commodity chemicals, fuels, things that have massive impact if you can crack them. So they're cheap. So you really have to get your technology optimized, because otherwise you can't compete. Otherwise you can't get that ethanol plant up and running. But we wanted to focus on things that could have a massive impact, not a specialty chemical, which could create a lot of value, but its carbon impact wouldn't be that big.
Mm-hmm. That's an interesting challenge of to get the scale that is interesting to you. You're going up against super cheap mass-produced commodities that are harder to compete with. So you mentioned that some of your product choices were actually corporate partners coming to you and asking for it, as opposed to you going door to door and saying, "Hey, we can make this for you. You know, would you like to sign up?" Can you talk about the, how do people find out what you can do, and what drives, a L'Oreal or whoever to approach you and want to set something up?
Yeah, and I misspoke. We did knock on a lot of doors, but actually L'Oreal is an example. They came in through our website.
Huh.
They reached out to us. They said, "Hey, we looked at what you're doing. We're really interested in learning more." So they had somebody who was scouting technologies and looking for approaches, and they came to us. Other partners we've gone to, or we've given a presentation just at a big meeting like this, and somebody will come to us and say, "Hey, can you do this?" We don't have enough partners that I can talk about now, but I think you'll see it's a mix. The challenge, to be honest, is that the technologies we're trying to feed are already in place, like ethanol to ethylene. Nobody runs a pilot or a demo because that's commercialized technology. So we had to get to a point where we had enough ethanol that we could put it into a commercial plan so we could make the products that our brand partners wanted, because a lot of these things don't get done. It's such old known technologies in general that they don't get done on this small scale that we had to be working in.
Gotcha. And what, I guess, what kind of scale do you need to reach to become a sustainable business, in terms of, getting out of the kind of build up phase and making money on this?
Yeah, I would say that we need kind of 10 to 15 commercial plants operating and making revenue for us to be at a point where I feel like our cash burn, which is pretty significant because we do a lot of R&D, you can tell, that we're whole on that. So we're also looking at new business models, so we don't have to wait for 10 to 15 years for that many plants to be up and running. So we're looking at maybe co-investing along with our partners now that we have some more cash, et cetera. So we're trying to modify the model and grow it.
Yeah, and you did say sometimes you're licensing. So are there any plants where it's your capital going in, or do you often try to just license the technology and not have to worry about building your own plant?
No, so now we're looking to partner and contribute capital as well. So we're starting to raise cash for the sole purpose of building these out more quickly. And I think if we contribute cash, we'll have the ability to, every time a new partner builds one, it's new to them. But if we're not just licensors, but we're actually involved in making the decisions, that'll be the eighth plant, right? So go much faster. The knowledge will make it much better. So that's what we're trying to do.
Yeah, no, that makes a lot of sense. And I'm sure it conveys, a good vote of confidence if you're putting your own money in and you've seen it work in other places and want to, equity in the new plant too.
That's right.
Gotcha. Do you have any wish list products? If you could build something else with recycled carbon, any outliers that you want to get to eventually in the roadmap?
Yeah, one of the molecules we're really focused on is acetone. I really like acetone because acrylics, all of these screens and windows and all of these things require acrylics, right? And I'd love to be able to start to make all of these types of things, all of these building materials, that's what I want to transition, right? So you can imagine a world where not only everything you use in your home, but even a lot of your home is made with some type of recycled emissions. That's my goal.
Oh, that's very cool. And then, I was thinking in terms of the companies that are approaching you and looking at your website, how much of that is driven by this newfound investor interest in ESG and sustainability? And are you able to gauge the sort of impact that has on actual supply decisions that these companies are making?
You know what? I would say that this whole ESG interest is latent. A lot of the companies we've been working with for 5 to 10 years before ESG was hot, but they were all already shooting, skating to where the puck is going, right? They already knew they had to do something in the future. So I think the new ESG interest hasn't become that important to us yet, but individual ESG interest is what's driven all of the interest in our company, all the interest in everything we've done, and the support we've gotten.
Gotcha. I'm still kind of fascinated by the idea of these ancient bacteria that evolved in a time when I guess there wasn't oxygen. And do you have any fun facts or scientific anecdotes you've learned along the way? Because that it's kind of mind-blowing that these things that evolved millions of years ago in a completely different Earth, could end up being so useful to us now.
Yeah, so actually, fun fact, which I don't always cite, is this bacteria is found in rabbit poo.
Okay.
And actually it's kind of funny because that also makes you think of all of this biome and ecosystem that's in our bodies, right? And these collaboration between bacteria and to make things work. And you'd be amazed at how important the this whole bacterial world. And I really believe it isn't just going to be us. So many people are working on bacteria right now and optimizing and making products. It's the future.
Yeah, so it's really this kind of interspecies collaboration in the hopes of saving the planet.
Exactly.
Yeah. Okay. Well, that's fascinating. And I guess we're just about out of time. So any kind of closing wisdom, vision for the future you want to leave our audience with?
Yeah, I would say go off and do the impossible things because that's what's going to save us. And this planet's actually worth it. So let's do it.
Well, definitely after hearing what you're up to, that definition of impossible does start to seem a lot more malleable than I previously believed. So thank you so much for being here. I would ask for a round of applause if we had the audience in front of us, but I'm sure they're clapping for you at home. And so, yeah, thanks for your time. Thanks to the engine. And then just quick programming note, there's now a 15-minute break coming up, after which you definitely want to be back because Matt Rogers, who co-founded Nest, is going to be talking, and that'll be fascinating. And then closing remarks by Reed Sturdivant, who's general partner at the engine. So thanks to you all for being here, and have a great rest of your day.